Circling coordinate geometry, let's have a look. Once you see a question circling coordinate geometry, what do? You open the table, isn't it? Because we're going to need those formulas. So here we have a equation of the circle. And what kind of equation? We know circle can be written in two forms, isn't it? We have those two forms of the equation now, a circle, the first and the second. And we can see that that is that second part. So that's the one we're going to be looking at. And here we are told that we have to write down the coordinates of the center and the radius. So when we have a equation, given equation of the circle in this form, how do we write the center? The center is minus g minus f. What is g? G2g, number that stand beside x. So in our case, our 2g, the number that stand beside x will be what? Minus 4. So in order to find g, we divide both sides by 2. And minus 4 divided by 2 will give me minus 2. And then the next one, f. F is what? 2f stands beside y. And what do we have there? 2. So our 2f will equal 2. Therefore, again, divided by 2, f equal 1. Now, don't forget, that's the way the center is minus g. So if I was to write minus and then put in the value of g, which is minus 2, you see we're going to have a situation of two minuses. Minus and again f, and f is 1. So that means those two minuses will change to plus. So we're going to have 2 and 1. And then the second thing is the radius. And the radius, here we have a formula. Now we've already figured out what is g. G is minus 2. So that will be minus 2 to the power of 2 plus f. F is 1, again 1 taken to the power of 2 minus, and then our C value, C is that number at the end, and our C is minus 20. So minus 20, again don't get caught with that, yeah? Everything under the square root, we put that in the calculator, press equal, and we get is 5. So we have the center and the radius. Let's have a look at next part. And then we have the equation of circle T, so a different circle. The previous circle, what was the name? S, and now this is T, and that's a different type of equation. And here they are saying that the circle, show that the circle S and T touch externally. Now, since we are talking about circle touching, let's just remember all different situations about circle touching. So here it is, 3 different situations how the circles can touch. So they can touch internally, they can touch externally, and they cannot touch. Okay, so let's consider each one of those situations. How can we investigate that? How can we show that? So the idea is that you have here, I know that's not going to be in the center, but I'm just going to put that, maybe, let's hold on, let me just look smaller the circle. Yeah, so we have the center. So center, I'm going to do it in different colors so that we can identify that. So here we are saying that this length from center to center, so we are saying length from one point to the other point, so from one center to the other center, will be as, and on the other side we are saying, well, this is the big radius, isn't it? So as the length of big radius minus, and this one here is what? Small radius. Yeah, and that's how we will know that they are touching internally. And again, now our situation externally, so one is center, and here I should do a different color, center, and again we have a radius and radius. So in this case, we are saying the length from one center to the other center will be the same as one radius add to the other radius. And then what about if they are not touching? So we have a center and we have a center again, and then we have one radius and the other radius. So here we are saying, well, if we calculate the length from one center to the other center, that length should be what? Greater, yeah, than one radius and the other radius, isn't it? So that's how we will know how they are touching. But our situation touching externally, that's the one. So we on one side of the equation going from one center to the other center and radius to radius. Now we have the center. So let's write our value so that we don't get lost. So center of circle S was what? 2 and minus 1. And then the radius was 5. Now we need to do the same in our second equation. Now that's that second equation of the circle. So again, when you look at your tables here, I'm just going to copy that part that has to do with the, oops, where did you disappear? Yeah, so that's our equation here. And then H is the number that stand in bracket together with X. However, not, it should be minus in plus. How is that possible? Because we had minus 14 that turned to plus. So that means that is the value of H. So that's my center, minus 14. And then again, I'm looking K here, 11, that's fine. So it's 11. And then radius to the power of 2 is 225. So radius to the power of 2 is 225. That means radius will be what? Square root of 225. And when we put that in the calculator, we get that that is 15. So here, let's still write that out. So the second center T. So here we have minus 14 and 11. And then radius is 15. Now, formula for the length, let's get that from our table. And we identify our x1 and 2 and all of those. So that will be my x1. Oops, that should be y2, y1. Oh, don't know what's happening here. So y1 and then x2, y2. Let's do our calculation. So on one side of the equation, square root bracket, x to our x2 is minus 14, minus, and then x1, that's 2. Now, does it matter which one is first, second? No. Oh, that should read 2. 11 minus, and then again minus 1 to the power of 2. And on the other side of the equation, one radius plus the other radius. We put this side in our calculator. We press equal. We get 20. And then 15 and 5, that's as well 20. So yes, both sides are the same. They equal. So yes, they are touching externally. We just proved that.